Hello, grade 8s. We're going to get started on Chapter 6. So this is for Lesson 6.1, just so that you kind of know where we're at. Chapter 6 is talking about solving equations, linear equations, and graphing them. We're going to start off with a couple equations, and just as a reminder, the difference between an equation and an expression is an equation will actually have an equal sign. An expression, if you have something like 2x plus 3, you don't have an equal sign. There's many possible answers for an expression. Okay? So we could take x, we could put in 4, we could put in 5, we could put in 6, we could put in 20, and our result is going to be different every single number. So when you have your input-output chart, that's when we use our expressions. When we look at our equations, we have a definite answer. Okay, so in 6.1, we're going to actually start with using models to represent each of these equations. So we're going to use integer shapes and kind of like scales so that you guys can kind of understand what's going on. So in this question here, we have 3h equals 42. So what that's going to look like on a scale is going to look something like this, where we have 3 individual h's, and that's going to equal 42. Now, what can we do? We can actually take this 42 and we can try to break it up into individual pieces. Okay? I want to try to find 3 individual pieces. Okay? So, what if I was to take my 42 and I was to put it into 3 pieces of 10? Okay, well, I would not use all 42. So if I was to have 10, 10, 10, that would be 30 of the 42. I'm still going to have 12 left. Okay, so I've got 12 that's still left over. I can start to divide that up. So if I want to go 1, 1, 1, 1, 1, 1, or 2, 2, 2, or someone might figure out that I can actually go 4, 4, 4. So that means in every single one of these, I'm going to get 14 pounds, 14 kilos, 14 grams, or whatever. Okay, so now I actually have 3 independent 14 weightish, weights. And on the other side, I have 3 h's. So I can actually pair them up and say that 1 h is going to equal 14. Okay, so that's one way that we can kind of look at this first question. Okay, how we're kind of breaking it up and how they still remain balanced. Okay, the next way is we're actually going to talk about the use of integer tiles. Okay, so I'm going to use the expression in this one, and I'm going to say 3j minus 5 equals 19. Okay, so if I'm saying 3j minus 5 equals 19, I'm going to use my integer tiles and I'm going to actually draw it out. So if I have 3j's, I'm going to use some long strips to represent my variables. Okay, minus 5, so I'm going to use my red. So I'm going to have 1, 2, 3, 4, 5, and it's going to equal 19. So positive 19. So I'm going to use my blue. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay? Now, I want to try to solve this equation. So what am I going to do? I am going to use my 0 pairs. So a reminder, a 0 pair is when you have 1 positive and 1 negative, okay, or 1 blue and 1 green, okay, and then they balance each other out. And like I always tell my grade 7s, math is always fair. So if I do something to one side of my equal sign, I have to do it to the other side. I'm trying to figure out what my variables can be when they're by themselves. So I'm going to start making 0 pairs on this side. 1, 2, 3, 4, 5. Okay, I've made 5 0 pairs. So now these are eliminated. They're no longer there. But like I said, what I do to one side, I have to do the other. So I go 1, 2, 3, 4, 5. Okay, so Now, I understand that my 3j equals 5, 10, 15, 20, 24. Okay? Now, I'm going to try to break them up into, so that I know exactly what 1 is equal to. So I'm going to start to make groups. Okay? So when I'm making my groups, I can say each group is going to get at least 5. Okay? I know that that's going to work out. So I've got 1, 2, 3, and now I'm left with 9. Okay, well, each of these is going to be paired with another group. So if I look at one particular group, I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 positives, okay, in one group. So this would be connected with this one will be connected with here, and this will be connected with here. So I'm basically dividing it, okay? I'm saying that J in this situation is going to equal 8. Okay, I can check it. Okay, I can say, what is 3 times 8? 3 times 8 is 24. 24 minus 5 equals 19. Okay, that's the second example. Okay, the third example, we have to kind of manipulate it a little bit more. Okay, so in my third example, I'm going to say 8 equals negative 6 minus 2x. Okay, this one's a little bit trickier because I actually have a negative variable. I have negative 2x. Okay, even though you're looking at it, you're like, no, it's negative 2. The negative 2 is actually connected with the x because when they multiply together, it still becomes a negative number. So what's it going to look like when I draw it out? Well, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. 8 positives. Okay, that's my 8. I'm going to have 6 negatives. 1, 2, 3, 4, 5, 6. And then I'm going to have 2 negative variables. Okay? I don't want to have negative variables. Okay, so actually the first thing I'm going to do is I'm actually going to move that to the other side. Or I'm going to add 2 positive variables to both sides. Okay, so I'm actually making 0 pairs with my variables. So I'm going to make one here, I'm going to make one here, and then I have to do the same thing on this side. So these actually cross each other out. When I have a positive x and a negative x, that they just subtract each other. Then I have another negative x and a positive x. But I added 2 here, so I have to add 2 over here. All right, now I'm getting so much closer to being able to solve this problem. Now I've got 2x, positive 2x, plus 8 equals negative 6. Okay, well now let's try to subtract make the 0 pairs to get rid of this positive 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. These are eliminating each other. I'm making those 0 pairs. So that means I added negative 8, so I have to do that again. 1, 2, 3, 4, 5, 6, 7, 8. Okay. I'm going to rearrange these a little bit. I'm going to move these 4 down and just kind of stack them a little bit better. Okay. It's just going to make the final process a little bit easier. Okay. So I've got all these that are gone. I'll just erase it so that you know and it's not looking too complicated. I've got these that are gone, okay, because I eliminated them with 0 pairs. Now, I've got 2x equals negative 2, 4, 6, 8, 10, 12, 14. This is divided in half. Now I'm just going to divide both of these in half. So I can say that 1x equals 1, 2, 3, 4, 5, 6, negative 7. So x equals negative 7. Okay, well let's see how that works when I actually try to solve the question. I have negative 2 times negative 7. Well, when I have a negative and I multiply it by a negative, I end up getting a positive. So I get positive 14. So now I'm saying 6 minus, or sorry, that's a lie. I'm sorry, let me rewrite this out. So if I'm saying 8 equals negative 6 minus 2 times negative 7, I'm going to have 8 equals negative 6, negative 2 times negative 7 equals positive 14. So now I have 8 equals negative 6 plus 14, so 8 equals 8. Okay? Those are the 3 types of ways that you're going to be able to use models to represent your adding and your solving of your equations. So try out your Math Makes Sense 6.1. There's also going to be a Google Forms doc for you to answer with a couple questions, as I'm sure you're familiar with. So try those out. And then if you have any questions, feel free to email me. I'm also available for Hangout video chat if you really want to kind of try to figure out exactly what's going on. All right? Happy working.